Hey, welcome back everybody. Let's go ahead and get started on our lesson today, which is going to cover scale factors and just some of the ins and outs of scale factors, what a scale factor is, how to find scale factor. Also, we're going to get into this thing called corresponding sides and corresponding angles. Make sure you guys know what those mean and kind of some general vocab. So let's go ahead and get started. Okay, to start it off, let's go ahead and go over some basic notes here on what scale factor is all about and some basic general ideas here on what scale factor is. All right, so the first thing here is a scale is the relationship between measurements on a drawing or a model and the measurement of the real object. And scale drawings represent a picture that is too large or too small to be drawn at the actual size. Now, one thing that always kind of drives me nuts about, when they show pictures of the Earth in proximity of the moon, and they'll always show this is not a great drawing right here, but here's the Earth, all the continents and all these great things. And then they'll show the moon like right here, as if it's just a stone's throw away or something. And it really isn't. If you really look at the scale of how far the moon is from the Earth, you'd be amazed. Now, I went ahead and pulled up a picture here that I have of the Earth with the actual accurate scale distance from the moon. This is not a lie. This is not a joke in one bit. This is actually the distance. It is pretty darn far. I think when Apollo 11 went to the moon, it took 3 days for them to get there. But this is the actual scale. Because like I said, most textbooks and I get it because they need to be able to fit it on a page, but most textbooks put the moon like right here, as if it's really, really close, and it's super far when you really think about it. And it's amazing too when you think about the moon being as far away as it is, and it still has an effect on our gravity. It has effects on our, the oceans, and the tides go in and they go out depending on where the moon is. I mean, that's amazing when you think about it, and it's still that far away. But this is no joke. If you don't believe me, look this up. This is the actual scale distance that the moon is from the Earth. I think it's something like 20 moons away if you were to count it. I'm just guessing off the top of my head, but I think that's what it is. Now, moving on. Now, this is one thing that's also going to be true about scale factors, and a lot of times for a lot of these problems that we're going to be doing, it's going to be assumed or it's going to be something that is inferred or whatever. But measurements on a scale drawing are always, always, always proportional. Now, proportional is something we talked about in a previous unit, but that just means they have the same ratios. They have equal ratios or equal proportions, the way they work out. And we'll get more into that later. Now, moving on to this next part here, just want to go over some quick vocab here, and I want to talk about this word corresponding. Corresponding sides or angles are in the same location for similar shapes. For basically they're different. They're in different figures or different shapes, I guess. I don't want to say they're different because that makes it sound like one's a square and one's a circle. But corresponding sides or angles are in the same general location for the same shape. So for instance, right here we're talking about angle A. Well, here's angle A right here. Now, what does that correspond to over on the other triangle? Well, that corresponds to angle D right there. So angle A corresponds to angle D because they're in the same general spot. That's where they are. Angle F is right here on that triangle, and that corresponds to that angle on the other triangle. So that corresponds to angle C. And then angle E is this right angle right here. Well, that corresponds to the other right angle. So same thing applies to segments. BC which is right here, BC, corresponds to this segment over there. So that's EF, segment EF. AB is right here, and that corresponds with that segment right there, which is DE, segment DE. And DF is right here. That corresponds with that segment right there. So that's AC. So that's how corresponding works. Corresponding means they have the same general location. This angle and the angle are in the same general spot. This segment and this segment are in the same general location. And that's how it works. Make sure that when you're comparing, especially when you're getting into scale factors, you're comparing corresponding sides with each other, and you're comparing as well corresponding angles. All right, so jumping into our first example here, what we're going to do for example 1 is we're going to find the scale factor from figure A to figure B. All right, so we've got to listen to the way these are worded. This one says figure A to figure B, and if you kind of peek ahead here, for example 2, it says find the scale factor from B to A. Now they're not the same, they're very similar. You'll figure out kind of a trick for it, which is not a very difficult thing to figure out. You definitely want to look at the wording of the question and look at what it says, from what to what. Now right here, this is what we would call, if we're looking at figure A to figure B, well, figure A is bigger, and then figure B, of course, is smaller. So that would be called a reduction. Now, I'm not going to require you guys to write all that down when you're doing your assignment, but it's good to know that it's called a reduction. Yeah, sometimes it's called a reduction or an enlargement. And this was an example of a reduction. The enlargement, of course, just means it's going to get bigger. All right, now in this case right here, it's a reduction. We're going from big to small. But what you want to do is you want to pick some figures out here, and you want to set up a ratio. So scale factor is going to equal a really simple formula right here. And what you're going to do for the scale factor, you're going to find the ratio of the new measurement over the old measurement. Okay, so for up here, figure A would be the old, and that would be the new. It's kind of like before and after, more or less. But you want to think of that as a ratio or division problem. And you want to be careful with that. Now here's one thing we do need. We definitely need some numbers here. So let's just compare some sides here. What is the length of that side? Well, that is 6 units right there. And on figure B, that one is 2 units. I'd be careful with looking at anything diagonal on a triangle, because that right there, is that 1 unit? Is that 1 unit? No, it's not. Diagonals are not the same as those things. That's a unit. That's 1 unit. That's 1 unit. Okay? This, not so much. Those diagonals are actually greater than 1. Just kind of keep that in the back of your head. I think I talked about that in class at some point as well during the regular school year before all this stuff started happening. So the new measurement, when we do this, the new measurement was 2, and the old measurement was 6. Now, if I put that in my calculator, if I do 2 divided by 6, I'm going to get 0.33333, which I don't like to, I don't like to get repeating decimals. If we can avoid repeating decimals, let's do that. What I want you to do is kind of just treat that as a fraction that you can reduce. So 2 over 6 reduces by 2. Reducing it like a fraction, and you get 1/3. So there's the scale factor right there. The scale factor is 1 to 3. Basically, we're saying that figure B is 1/3, or I should say that figure B's segments are 1/3 of the segments of figure A. That's what's happening there. And like I said, if you can, avoid repeating decimals. And then for example 2 here, we're looking at it the other way around. We're looking at it from B to A. So we're going to still do this the old way. We're going to do, this is our old figure. That is our new figure right there. So figure B, we're still going to do new over old, the ratio of new to old. So new in this case is going to be 6, and the old is 2. And then this actually works out. 6 divided by 2 is 3. All right, so we got a scale factor there of 3. Okay, now moving on to example 3 here. What it says is we're going to find the scale factor from figure A, that's going to be our old number, to figure B, which is going to be our new number. This is our before, according to this example, and this is going to be our after. So that's what's going on there. We've got figure A to figure B. And then there's one more added step to this. What we're going to do is once we find that scale factor, we're going to use that scale factor to help us find x. And I'll show you how to use that. Because once you know what the scale factor is, it's really easy to find perhaps missing parts or missing angles or missing sections, missing measurements or whatever they are on similar shapes. What I'm going to do is I'm going to highlight just a pair of corresponding sides. I'm going to try to compare corresponding sides that have two numbers that work together. Like I wouldn't start with x and 6 because there's nothing there for x. So we're gonna let's hold off on that x and comparing anything with that x yet. But let's compare 13.5 to 7.5. So again, you're gonna do, when you do this, remember you want to do the ratio of new over old. You want to do new to old. So in that one we're going to use, I'm using 13.5, 13.5, and the old is 7.5, 7.5. And this is where you can kind of plug it in your calculator. You get 13.5 divided by 7.5, and I end up getting a scale factor of 1.8. When I do that math there, I get 1 8/10. So that's your scale factor. If you want to see how that kind of all pans out here, let's take another number. Let's take 4, and let's see if that works. Let's say I take the number 4, and I multiply that by the scale factor. Well, 4 times 1.8. Now, if you do that, 4 times 1.8, what do you get? You should get 7.2. And you can check that on your calculator if you don't believe me, but it is 7.2. And that's exactly what it is over here. So that's how you know you're dealing with, especially that's how you know you're dealing with similar shapes, because the scale factors all work out the same way. So if we want to figure out what x is, well, we're going to take that corresponding side right there. We're going to take that corresponding side, 6, and we're going to multiply that by the scale factor, SF, right? So 6 times 1.8. And when I do that on my calculator, I get 10.8. So that ended up being 10.8 inches. And there you go. So our scale factor was 1.8, and this was kind of a mess, but if you do 4 times 1.8, guess what you get? You get 7.2. When you do 7.5 times 1.8, you get 13.5. When you do 6 times 1.8, you get 10.8, right up here. And that's how that scale factor works, because it works on every corresponding side. Now this last one, just like we've been kind of doing before, why don't you go ahead and try this on your own, see how it all works out, and then compare your answer with mine to see if you did it right. So right now is a good time to press pause, and when you're finished, press play and see how everything kind of worked out. And then we're going to use that scale factor to tell us how to figure out what x is. So what does x correspond to over here? Well, it corresponds to 8. So I'm going to take 8 centimeters and I'm going to multiply that by the scale factor, and 8 times 1.5. So 8 times 1.5 comes out to be 12. So there's your x. Okay, so that does it for the lesson and guided practice here on figuring out scale factor. Hopefully you guys understood this and are getting it okay. We're almost at the end here of the school year, guys, and hopefully everything's going well for you. Let me know if you need anything. Please email me any questions or message me, whatever you can do. Set up a Google Meet if you need to, and I'll help you out. All right. Have a great day. Take care.